In this lecture, we're going to code along through the solutions for the previous function practice problems. Let's get started. Okay, let's begin with this warm-up section. And this one was called lesser of two evens. We wanted to write a function that returns the lesser of two given numbers if both numbers are even, but returns the greater if one or both numbers are odd. So here we have our function, and it takes in a number a and a number b. The first thing we want to do is probably check if the numbers are both even, and that way we have an if statement. So we'll say if a mod 2 is equal to 0, so that is to say when you divide a by 2, does it have a remainder of 0, indicating that it's even, and the same for b. b mod 2 is equal to 0. So if this statement happens to be true, so if this condition is true, that means we have both numbers are even. So I'm going to say here both numbers are even. And in this case, when both numbers are even, we want to return the lesser of the two numbers. So we'll say the following. We're going to say if a mod 2 is equal to 0 and b mod 2 is equal to 0, let's check the greater number. If a is less than b, we're going to say result is equal to a. Else, result is equal to b. And off of this, what we're going to do is say else. So now, one or both numbers are odd. And in this case, we want to return the greater. So we're doing the exact opposite here. If a is greater than b, say the result is a, else the result is b. And then all the way at the end here, we can return the result. Notice the indentation here. All right, so this is one way of solving this problem, just using a bunch of if and else statements. So let's run this and confirm that it's actually working for us. So lesser of two evens, looks like it's returning 2 here. Lesser of two evens, if one of them is an odd number, it's returning 5. Let's make them both odd just to check. And now it returns 7. Great. So this is a viable solution for this problem. However, we can actually clean up this code a lot more. And in fact, there's a way we can run this chunk of code automatically, and that's using the min function. Previously, we saw how the min function can actually return the minimum value of a list. But if we take a look at what happens with minimum function when we pass in two numbers, such as 10 and 20, it actually returns back the minimum of the two numbers that you're comparing. And it works with just two numbers. If you want more than that, you'll have to pass in a list. But it also works the same with the max function. So then it returns the max, either 20 here when you pass in two numbers. In which case, all I need to do is the following. I can say result here is equal to the max of a comma b. And I can then say here, result is equal to the min of a and b. So we've been able to clean this up even further. And now if I run this, let's check to make sure we get back the same results here. So I get back 2, and I get back 7 when I rerun those cells. Perfect. And in fact, we can take this one step further. We can actually have multiple return statements inside here, because once you say return and it gets executed, the function will stop. So instead of saving these as results and then waiting until the very end to return your result, what we could do is just say return min AB over here, and then say return max AB over here and delete this last one. So then what's going to happen here is your function's going to go along and it says, hey, if both the numbers are even, go ahead and just go straight to returning the minimum value between A and B. Else, then go straight to returning the maximum value of A and B. And this is probably the most efficient way to do this problem. We could make it a little sleeker, maybe try to put it all in one line, but this right here is a better solution than what we saw at the very first run. And this is what you're going to see in the notebook. All right, the next question in the warm-up section was this question called animal crackers, where we wanted to write a function that takes in a two-word string and then returns true if both words begin with the same letter. So here I can see level-headed and llama both begin with L, so we return true. Crazy kangaroo begin with different letters, so we return false. So let's build this out. And we're going to do a similar thing as last time. We'll build out all the logic and then see if we can make it a little sleeker by using some keywords. So the first thing I want to do is actually grab the two words. So I'm going to create a variable called word list, and set it equal to the incoming string. And to grab the 2 words, I can use split. And now I should have a list of the actual 2 words. So let's just print out word list so we can confirm this. So if I run this, now I see that I'm getting back a list of 2 words. And what I want to do is check, is the very first character in this word matching to the very first character in this word? So I could say that my first word is equal to word list at 0, and my second word is equal to word list at index 1. And then I want to return is first 0, meaning is that first letter of the first word equal to second 0. So is this first letter equal to the first letter of second? So now when we run this, I get back true, and I get back false here. And we can take out this print statement now to see just the Boolean results. Now we could actually edit this a little bit. In fact, notice here how I'm essentially making 2 index calls, 0 and then another 0 here, and then 1 and another 0 here. So what I could do is not even bother with this assignment, and instead just grab word list itself and replace it for first here. And then I could grab word list 1 here and replace it for second there. And now this is the exact same thing, except it's now using a double index call. So when I run this again, I get back the same results. Something to notice here that I'm not actually checking is just in case these 2 letters, right now they're both capitalized, and we're assuming they're both capitalized, but maybe one of them is lowercase, and I'll show you what I mean by that. Let's imagine we have crazy cat with a lowercase c. If I run this, it's going to return false, even though they are starting with the same letter. In that case, what I could do is lowercase my word split, lowercase my text, before the split. So I could say text dot lower, and then after that, call the split. So I could either do that in a new line, but Python actually allows you to kind of tack these on one right after the other. So I'm going to do lower and then do dot split on this. So now let's run this again. And now we can see that it confirms true because it's making everything lowercase before it actually does the split. And we can see that by printing out that word list. And if I run this again on crazy cat, I notice here crazy has now been lowercased. And it would have worked the same way had we used upper, because then it would have just uppercased the cat there. So it would have confirmed capital C matches capital C. All right, so that's the basics of that animals crackers problem. All right, our last warm-up problem is a little more math-based, and it's called makes 20. And we wanted to know that given 2 integers, return true if the sum of the integers is 20, or if one of the integers themselves is 20. If neither of these is true, go ahead and return false. So let's check through these 3 cases. First, we need to check, is the sum 20? So you can say if n1 plus n2 is equal to 20, return true. And then we can have elif cases for the other ones. We can say elif n1 is equal to 20, return true. elif n2 is equal to 20, return true. And if none of these happen to be true, then we can just return false. So when I run this code and I check it, it looks like it's working. So 2 and 3 is false, 20 and 10 is true. And if we do one that sums up to 20, 10 and 10, that also returns true. But as I previously mentioned throughout the course, if you're already checking if some Boolean statement return that actual Boolean, then what we could do is put all of this on a single line. So how do we actually do that? Well, notice it's just a bunch of Boolean checks here. So we can use these comparison operators along with a logical operator such as OR. So all we actually need to do in one line is say return n1 plus n2 equal to 20, or n1 equal to 20, or n2 equal to 20. So let's check out how this is the exact same thing as all this code that we just wrote here. We're saying check if this Boolean condition is true, or this one happens to be true, or this one happens to be true. If none of these happen to be true, then we return false. So this one single line of code is doing the same thing as all of this. And we can check it out by running this, and we get back the exact same results. All right, that's it for the warm-up problems. Coming up next, we're going to go over level 1 problems. We'll see you there.